Okay, so let's take a one single machine, that is single computer, which is having a 2 GB RAM and a 2 core CPU, which is a low-end machine. Okay, you want to perform some task, you have some 1 GB of data or some 500 GB of data, you want to perform some task on this. Is this system is enough to handle that this much data or store and process? Like on one more example, like 100 GB hard disk. Okay, I have some 20 GB data. Okay, so will I be able to store and process this 20 GB data in this machine? So please try to interact with the session.
Yeah, you can, but it I don't know. The performance can be a issue
The
also.
performance is secondary, so at least you will be able to store, right?
Yeah.
Store a bit of processing, right?
Yeah.
So that is good. At least, I mean, this system is able to handle this one. Okay, now the requirement has changed. Now this time we need to store some 150 GB of data. 150 GB of data. Now, does
We
this machine will be able to handle?
can't handle.
So what is the next thing that comes to our mind?
Yeah, you
You're gonna
increase the hard disk, right?
upgrade the hard disk under the configurations according to
Other
the.
configuration also, not only the hard disk
Yeah,
configuration will
so
not only help you.
let's say I'm not doing much of processing and improving the hard disk is enough. Let's say, okay, even RAM you can upgrade, other things you can upgrade. Let's say I'm taking some 250 GB hard disk. 250 GB hard disk. At least now I will be able to store this data. Okay, after updating some configurations. So the requirements keep on because day by day we keep getting the new data, like data volume is increasing. So now I got some 500 GB of data. So again, we have to increase some 150 GB or 1 TB, like we have to increase along with other configurations. So the same way, I got some 2 terabytes of data or some 1 petabyte of data. So can I one single machine will be able to handle the data?
No.
No, you need a cluster of machine probably to help.
Because one single machine, there is hardware limitation, right? You cannot upgrade a single machine beyond certain limitation. Beyond certain limitation. So even if you're buying a mobile or laptop, they give maximum you can upgrade up to this much storage and 64 GB RAM or 64. Like they give what is the maximum capacity your hardware supports. You cannot go beyond that. That's the bottleneck. So to add that, this is the called as vertical computing. This concept is called vertical scaling. Vertical scaling. But in the vertical scaling, we actually scale like one machine. We can keep on upgrading existing machine. So since there is a bottleneck for this vertical scaling concept, there is a new concept to come that is called horizontal scaling. Horizontal scaling. So in horizontal scaling, what happens? So the same existing you have one machine with limited configuration, and whenever you need some extra configuration, instead of upgrading the existing machine, you keep on adding the new machines to the keep on adding the new machines. Okay, so since there is a bottleneck, we cannot scale one single machine beyond certain limit. So we have one more concept called horizontal scaling. Okay, most of you know this concept, just I'm reiterating. Okay, so horizontal scaling. So this is having some some 2 GB RAM, okay, and some 100 GB hard disk. And similarly, like whatever the configuration you want, we keep on adding the machines. So there is no limit on how many number of machines you need. When the Yahoo started this Hadoop cluster, okay, so they started with something around 10,000 node to test. 10,000 nodes, really huge, 10,000 nodes. Okay, they're all connected. If you give any data, if you give some 1 peta of data, so keep on adding the machines, divide this data into smaller chunks. This is the 1 TB data. Instead of storing in a single machine cannot fit. So each machine will take some portion of the data. But who will do this job? It's okay. Now I'm saying, okay, you have given it, you have certain amount of data, you cannot store in a single machine. What I'm doing, I'm just splitting the data and storing into multiple machines. But who will do this? Isn't it something manual task every time someone has to perform? Even you're running some script, some Python or any other scripting on this data, you have to manually copy the script to each machine, run your script against this data. Once that is done, collect the output from all the machines. So isn't it some overhead for us?
Yeah.
Right. So this is the overhead, right? So we need someone who can automate this process. So this is actually distributed computing. So we are actually distributing the data and computing parallelly across the multiple machines. So Hadoop works on this principle. Most of the cloud systems are these new systems works on the horizontal computing and distributed computing. So this is distributed computing. Hadoop works on distributed computing concept, horizontal scaling. That's why we say in Hadoop cluster. Cluster is nothing but what? Just a group of computers. All are computing in a network together to perform some task. Okay, so that's why since we have to this is actually having manual process of like we need some system who can split the data, store into multiple machines, monitor, run the scripts, collect the output. We need some kind of system. Okay, so that's why there is a one concept called Google introduced one white paper. So based on that white paper, so Doug Cutting, who actually inventor of Hadoop framework, okay, based on that he built one Hadoop framework that is called MapReduce. MapReduce is the framework. It is the distributed cluster computing framework. Cluster computing framework, MapReduce is. So here, so the MapReduce will take care of, okay, MapReduce is the framework, okay, it is a framework. Distributed cluster computing framework. So what are the bottlenecks or limitations which I told? Okay, this MapReduce framework will take care. Whenever someone give the data, so store it, like process it across the multiple machines parallelly, then get the output, that is aggregation from all the different nodes. So this will MapReduce will take care. So and MapReduce works on top of Hadoop HDFS file system, that is Hadoop distributed file system. That is where Hadoop stores the data. So Hadoop's native file system is HDFS. That is something there is some virtual layer on top of our operating system file system. So generally, like we install Hadoop in Linux machines. So Linux machines have some ext4 or ext3, some different file formats. That is the native Linux file formats. Okay. So on top of the same operating system, on the same operating system, okay, when you install Hadoop is just like a one software. Okay, so when you install Hadoop, okay, that is create a virtual layer on top of your same hard disk. Okay, you have some file here. Okay, in local file system, for example, you take in Windows. Okay, so you have some file here. The file which is local to your operating system, not in HDFS. HDFS is also in same operating system, which is installed virtually. Okay, so but if you're seeing some file here, that is only here, not here. If you want to move that, you have to move that with some commands. There are some HTTPS commands. With that, you can actually play with the files in Hadoop file system, moving, reading, deleting, copying, downloading. Okay, so there are certain different operations which you can perform on the data HTTPS, like how we can do locally. So those things we'll discuss later. So HTTPS file system is a one distributed file system. So if you store one file in your operating system, where does it stores? In your local hard disk or in some different system hard disk also?
Virtual hard disk.
No, if you're storing some file, okay, I'm storing some file in my Windows laptop. That means it is local to my Windows laptop only.
Yeah.
Even if you have some cluster of 10 machines, it does not show, I cannot access this file from different machine, right? So, so there is a hard HDFS. If you install, if HDFS layer is on top of this system, okay, if you put some file into HDFS, if you put some file into HDFS, okay, there are whoever the system which are connected in a cluster, which are so they all, so this file is not stored in a single system. This file is further split into like in the distributed computing how it does. This file further gets divided into multiple chunks and stored across the multiple systems in the cluster. So the same file can be accessible here, can be accessible here, can be accessible here, because the file is distributed and the file is not in a single system like local file system. Okay, but how does this data gets divided? On what basis? If you have 1 terabyte of data, is it like some 200 GB here, 300 GB here, 400 GB here, 100 GB here, is like that? Any idea?
Block size based on the blocks, 128 MB. Default size of HTTP is 128 MB.
Yes. So if you do that, we really lose the um, advantage of parallel computing. So the same thing, if you store this into some 500 GB here, 200 GB here, 300 GB here, again, so what if this system crashes? Or the system crashes? We are losing the partial data. We're losing some partial data. So that means we need to have some backup. Again, so you have some Python script, okay, so some Spark script. You're running the data. How many instances you are parallel running here? How many threads you are parallel running on the data? Only 3 threads, right? So we are actually, still it is getting the parallel computing, but still we are not taking the real advantage of parallel computation. Okay, so that's why Hadoop came with the concept called as block. So let's say this file size is this is one machine one, node one in a cluster. This is some 250 GB hard disk. It is having some 250 GB hard disk. This is having some 100 GB hard disk, because all nodes cannot be on the same size. It can be of multiple different sizes, different configurations. This is some 500 GB hard disk. Okay, I'm taking one simple data, 1 GB. 1 GB data. So where this 1 GB data I can store across these 3 machines?
Yeah.
Sorry.
Yeah, you can.
Where can I store? In which machine?
No, you can store in all the 3 machine divided by blocks.
Okay. So blocks is the next concept. So generally, we can store this data anywhere in this, because all these 3 machines have the sufficient storage. Here also I can store, here also I can store, here also I can store. But if you do that, so am I getting the advantage of taking the advantage of parallel computation? No, right? Only one single task will be running on top of this 1 GB data, right? So that's why Hadoop doesn't store the data in this way. Okay, so there is a block size concept. Okay, block size generally starts from some 128 MB or 256 MB, okay, or 512 MB. So based on, this can be configurable from the configurations. What the block size? So based on the block size, this file gets divided into. So 1 GB means 1024 MB. 1024 MB. So if I choose the block size as 256 MB, so that is 4 blocks. 4 256 MB blocks. Okay. So if I take the 4 256 MB blocks, one block is storing here. Some portion of the data, 256 MB data storing here, and other 256 MB data storing here. Some other 256 MB data storing here. Okay. So and some other block can be stored anywhere here, anywhere in this machine, whichever node has sufficient storage. We have that name node is there that will decide where to store. Okay, so now we stored this data across the multiple machines, but are you seeing any bottleneck here? Any problem? What if this node crashes? Or what if this node crashes? So we are losing the access to the data.
Yeah, there are duplicate copies they maintain, right?
Yes.
Like,
so that's to handle this fault issues, crashes. So Hadoop has fault tolerance concept. Fault tolerance. That means fault tolerance with the help of replication factor. Okay. By default, replication factor is 3. Replication factor means how many copies of the data you want. Okay, how many copies of each block you want in the cluster? If you say replication factor is 3 means each block will have total it will have 3 copies in your cluster. It will have 3 copies in your cluster, each block. So this is block 1. Okay. Okay, now block 1 is here in node 1. So now I'm doing replication factor is 3. That means there is a default replication factor, and this also can be configurable in HDFS per file or across the cluster. So that normally that is managed by Hadoop admin. Okay, but 3 means each block will have 3 copies in this cluster. So this block is here. Okay, and the same block, it is here. We cannot store the same block here. If we store it, if the system crashes, there is no point of a copy of the data. So store the other block here and block here. Copies of this block here and here. Okay, the same way this block 2 here. Okay, the same way block 3 here. Okay, again block 4 here. Now see, are we handling the fault tolerance? If any failure comes into any nodes, okay, if any node crashes, okay, even if this 2 nodes crashes, still we have access to the data from 3rd node. So Hadoop is fault tolerant by the replication factor. So this replication factor is configurable. Default replication factor is 3, and so for storing 1 GB of data, since we are maintaining the 3 copies of 1 GB, that means we need into 3 GB of free space in your cluster. Okay, based on how critical your data is. So accordingly, computer will take decision how many copies of the data you want. Okay, this one is actually which block has to store in which node. That is actually decided by rack awareness. There's a concept called rack awareness. Okay, we'll discuss this later point of time. Rack awareness. So, but we are doing, okay, this data we are storing, we are splitting this data and storing all the things we are doing. But who will do this task? Okay, I'm running some Python script. Okay, some Spark job or Python script or any Hive or MapReduce, anything I'm running against this data. Okay, so the request has to go here. All this, against all these 4 blocks, our code has to execute. But who will do that? that MapReduce framework will do that. So these days, MapReduce concept is outdated. Okay, because it is not supporting. It is actually performance-wise, it is good only for batch processing, and it is slow. Moreover, it's not good for any machine learning, or it is not good for any streaming data processing. If you have some streaming data coming, and this streaming data MapReduce cannot handle. MapReduce is only good for batch processing. So there are some limitations of MapReduce. Why MapReduce is slow, and why? So alternative to the MapReduce, one Spark framework is coming. Okay, so why Spark is taking over the MapReduce? I will discuss. There are some other tools like in MapReduce Peak. They're all fading out. Hardly anyone is using these tools. MapReduce, so Hive, hbase, or Spark. Okay, some other tools which are going. Okay, so but who will? So when you give the some data, so how my MapReduce program knows which block is stored in which location, in which node? This is data node 1. This is data node 1. This is data node 2. This is data node 3. Okay, so but how my MapReduce program knows which block is stored in which node? It doesn't know, right? So someone has to organize that, or someone has to manage that. So any idea who will do that?
Name node has meta information, metadata.
Yes. Yes, name node. There is a one name node concept. Name node, or we call it the master. Or we call
Sorry,
it the
Ravi, I able to see your screen.
sorry.
I can't able to see your screen.
Okay. Others, Venkat, Vishnu, Vardhan. Do you able to see my screen?
Yeah.
Photo, I'll just wait for a minute. Can you rejoin?
Yes, yes. Yeah,
Very good now.
I'm able to see.
Okay. So these are called as data nodes or slave nodes. Data node or slave node. Okay. So this is called as master node or name node. So responsibility of the master node is to maintain the index. Like similar to that. If there is a textbook of some 2000 pages, so it is difficult to say, right, which topic is in which page, which diagram is in which page. So will you be able to easily get that information? Okay, without index page? Difficult, right? So in our textbook, we get the index. The same way, so here also there is a file called emp.csv. I'm storing this into the cluster. The cluster gets divided into, in this cluster, that file get divided into multiple blocks and stored across the cluster. Okay, but if I want to read this file back, So I need to know where this file is located. It's good that you split it and you did that. But if you want to read that back, so give me the location where this file is located. So that index is managed by our master and name node. So this gives like, okay, this emp.csv block 1 stored in data node 1 in this location. So the same emp for the emp.csv block 2 stored in data node 2. So like that, it will maintain some index. So when someone wants to read the read, first they'll connect to this master node. Master node gives this block locations, and it'll connect to this nodes. They're all connected. Okay, and the file will be read and it will be sent back to the user who requested for this data. It may be program, or it may be a command, it may be a script, anything. Okay, name node basically maintains the this is called metadata. This is called as metadata. This is the actual data getting stored in data nodes. Metadata gets stored in the name node. Okay, and moreover, what are the other responsibilities of the name node? So if you want to store some, okay, orders.json, I want to store this. So who will decide? So this data, how many blocks I have to split at the same time, uh, which data nodes I have to store. So for demonstration, I've taken 3 nodes only, but we can have hundreds of nodes in a cluster. So how does it take a decision which nodes in which data nodes I have to store this data? Okay, so that's why what it does. So continue. So this name node or master node uh, keep getting the health of this. It monitors the health of the slave nodes also. That means so for the periodically for every few seconds, all these data nodes or slave nodes send some kind of heartbeat signal to the master node saying that okay, I'm alive, and some kind of statistic send. That means like okay, I'm having 250 GB hard disk, 250 GB, and I'm running this many processes, and right now I'm only 1 GB free. I'm only free of 1 GB. Rest of the size I'm filled. Okay, so that kind of statistics sent. So at any point of time, our master node knows about completely availability of the cluster, which nodes are up, which nodes are down, which nodes are how much occupied, how many jobs are running in which node. So all these things are monitored or tracked by master name node. If you want to store any other file, okay, first it's based on, because it knows the completely availability of the cluster. So it knows where to store. If this node saying that if this node is completely full, I cannot store this. That means choose some other nodes randomly. So while choosing, so one first node will be the nearest first node which chooses it will be the nearest node, whichever is nearest, because the cluster may not be always in the same location. So 10 nodes may be in India, other 10 nodes may be in US, other 10 nodes may be in Malaysia. There may be in different locations or different data centers. So first block, which is nearer data center, okay, and the rest of the replication blocks will be in the some remote data centers, which are far. When you want to read the data, you will have one copy locally, and moreover, if your local data center is down due to some natural calamities or anything, okay, still you have the copy of the data. The next copy, the rack awareness, first copy will be in the local, and next copy in the nearby, and the other copy can be in distinct. So this way we can even handle the um, other disaster recovery. Even if some disaster means some natural calamities or some complete power shutdown for the entire cluster in Bangalore data center. Okay, and you have some other data center in US which are there. We are hosting some 10 nodes. Still, you are able to access. If you keep all the data in single location, if all the clusters look in single location, if some disaster comes, your complete cluster is shut down. But this way, at least you will have the uh, although it might be slow, but you still have the copy of the data which is safe in some other geographical locations, right? So those things there is a rack awareness algorithm. Actually, we don't have to do that. Okay, rack awareness algorithm is provided by Hadoop framework which handles this. So admin will configure that. Okay, so any questions till now?
No, I'm good.
Okay, good, right? Gautam, Venkat.
Yeah, I think it's
No, I don't.
Yeah, good.
Okay, so in the when it comes to curriculum, what we hope, hope you already seen the curriculum. Okay, so if anyone doesn't see, so I just want to reiterate. Okay, we will discuss about this yarn architecture. Okay, and Hadoop fundamentals. I mean, um, important in terms of interviews also. Hadoop fundamentals. Okay, Hadoop commands. Since we are working completely on the Linux file system here, so we need to know at least some knowledge on Linux basic commands. Okay, and then Python, Okay, we'll give some intermediate knowledge in Python. I don't teach very advanced level of Python. That may not be necessary for working in data engineering. And Python, then MapReduce. I don't teach MapReduce I teach only core concepts of how does it works, but I don't go into programming because that's a waste of time. No one will ask. No one is using or ask in the interviews. This one. So at least you should know there is a concept of MapReduce, how does it works. And then Hive, hbase, scoop, flume, okay. And then Spark core concepts, RTDs, data frames, okay, Kafka, Spark streaming. So Kafka, Spark streaming. Then when it comes to AWS EMR, AWS EMR, Lambda, Glue, DynamoDB, this is okay, and bit of Redshift and S3 file system. S3 it comes with EC2, like EC2 is one more VM instance. So on top of this EMR will works. Okay, in the end, by using all these things, I'll give in between. I'll give some assignments to get you hands-on, and in the end, I'll explain some couple of projects, like from ingestion to delivery of the data. What are the different stages in the data, in our data pipeline? So data engineering means. So do you know the difference between a data engineer versus the data big data developer, data analyst?
Not sure.
Okay, so these are quite confusing roles. Okay,
Mm-hmm.
not everyone faces this issue. Some people ask, okay, so are you a data engineer or big data developer? What's your answer?
Preferably the first one, data engineer.
But why can't you? Because you're working with big data and you're developing the solutions for big data. Why analyzing the big data? So why not big data developer?
Big data is when you touch on big data, it's basically you're going core into much of HDFS system and all those things you will be using, right?
Big data doesn't means that working with HDFS. Big data, Hadoop is actually HDFS. Hadoop is one framework which helps you to store and process the huge of big data. Big data is Hadoop is just one framework. Okay, instead of HDFS, you can store in S3, you can store in Blob, or if you have any other file system, you can store there. If you're using Hadoop cluster, then only you can store in HDFS. Otherwise, you cannot.
Okay.
Data engineer only deals with the pre-processing. Not apart from that, he won't do any other things.
Somewhat right, but not exactly. Any other answers? Most of the companies gives these roles as like, I mean, same, but very few companies ask like, what exactly data engineering is. Data engineer does all the plumbing operations for your data. Like your data is coming from some system, you have to download the data, you have to clean the data, or like your data coming from some RDBMS or IoT or some other streaming systems. You have to get the data, store in a certain format, okay, ingest, store, okay, process, clean. Then then big data developer comes into picture who can actually use this data to develop or analyze this data, or big data analyst. Okay, so data engineering responsibility is to build the pipeline, not the analysis.
Got it. Yep.
Okay.
Yeah, it makes sense. Yes, you're right.
Engineer what simple. Like if you're building constructing a building, engineer will give you a plan. and other workers, developers, workers are like developers. They actually construct the home, but data engineer is not construct. I mean, engineer is not constructing. He's just giving a plan on how to do what to process. Similarly, here in data pipeline, you're not analyzing data. You're actually building a pipeline like all the plumbing operations you're doing to get the data in a way that how downstream system looks. Maybe a data science team, maybe a data analyst team, maybe some other BA team, whoever it is. Downstream team. Consumers of big data engineering team can be anyone. Data analyst, BA teams, or data science team, or any other teams. So, but many companies just they interchange these terms. Okay, even though you're a data engineer, they say big data developer. Even though you're saying data analyst, they say data engineer. They are quite interchanging roles. Only 10% of the companies very specifically ask these kind of things. Data engineer or data developer.
Got it.
Okay. So I will cover with not Scala Spark. I cover with PySpark, but Scala is also when it comes to Spark, there is not much difference into Scala versus Python when it comes to Spark implementation, other than core Spark programming or Scala or Python programming. But I'll tell you how it is different. Scala is different from Python when it comes to Spark implementation. Most of the things are same. When I go with that, I'll show you examples of Spark, Scala versus Python. So that will you will get familiar with both.
All right.
So when you say there was one question that you were going there that nowadays no one is using the what do you call it, MapReduce and it is
hardly people are using because
correct.
Many companies, I mean, maybe 10% of the companies are using MapReduce, but 90% of the time they are using Spark.
Okay, so in this particular thing, will you be very much in depth into Spark? That's what I'm.
Yes,
like
yes.
PySpark and all those things.
Yes. Yeah.
Okay.
It'll be Spark is completely hands-on, so I don't generally run the slides. Okay, it'll be completely hands-on.
Okay.
I'll just use the paint screen to explain the concept. Then I'll go into cluster or for doing the hands-on.
And the whole programming, right? This what do you call it? The access to lab and all those things. How does it happen?
Yeah, I'll come to that point.
Yeah.
So because not everyone's because this one need at least at least 80 GB or 16 GB of RAM to comfortably work on the system, right? So and that's a bit challenging task too. That is very slow also in the local system. That's why what I recommend to people, okay, Google in the GCP, Google Cloud. So there is a one cluster called DataProc. Okay, I will help you how to set up your DataProc cluster. This they give DataProc this GCP access. If you register with your credit card, I think debit card is accepted or not. I'm not sure. Okay, they'll give one DataProc cluster. DataProc cluster is similar to EMR. Okay, that is a managed Hadoop cluster in the Google Cloud environment. So you can use for 3 months. They give you some 22,500 INR free credits. That is more than sufficient for you to get this in the 3 months. So there you can actually create a multi-node cluster. Whenever you want, you can use it, shut down. You can do whatever you want.
Okay.
That is the best way. I feel that even if you practice a local system that is only a single node, if you run some 1 GB data, it'll become slow. That is GCP is free for 3 months. After 3 months, if you still want to continue, they'll take the charges or without your consent, they won't charge you anything from the credit card. If you say yes, then only they'll charge. But in AWS, if you're using any paid services, they'll charge automatically without your consent. But in Google Cloud, once this 20,500 expires, then only they will start charging from credit card. That too only if you say yes.
And generally, how much time? I know it all depends on our dedication and our putting how
Yes,
much
yes.
effort we are doing in this one. But let me ask you, realistically, right? See, I am doing a full-time job, and like I also have other. I'm be very honest with you. Okay, we have to do work at home and all those things, right? Because I'm not in India. I have to do work at home and all those things. So I'd be very realistic. I don't get a mate out there who can do your work out over here and all those things, right? So that being said, okay, uh, generally, what is the time frame do you look that a candidate should finish this one within this timeline?
Okay, so this course it takes around 2 months to
Okay.
complete. So, well, okay. So if you're putting extra efforts every day, okay, along with me, because if I give 4 examples, the rest of the 2 examples you have to practice on your own, because everything cannot be possible to teach everything, right?
Got you.
So I'll
So-
give like 2 months approximately. It will take 2 months to finish this course, and like based on your how much time you're spending, because some people will take 10 minutes to understand, some people take 1 hour to understand the same concept.
Got you. Yeah. Correct. Okay. So you were saying around 2 months, right? And how much of time and effort you have to put per day you are expecting a candidate should put out there?
So at least 1 to 2 hours, 1 to 2 hours after my session, because you have to do hands-on.
Okay, 1 to 2 hours after your session. Okay.
Yes.
And how long your session will run?
It runs around 1 hour per day, 1 to 1.5 hour per day.
Okay. And it's how many days a week?
It's around 5 days a week.
Okay.
Sometimes
So
if
means
you're available, we can take on weekends also.
okay, got you. So if your session starts at say example, I'm in Eastern time zone, so your session will start at 8:30 or what? What is the time
So,
I'm looking?
so I'm running one more batch right now. Okay, that will get finished in a week. Okay. So right now, that's why I'm keeping for 7 o'clock, IST 7 o'clock. IST 7, that may be 8:30 Eastern time zone, right?
Yep. Yeah.
So maybe going forward, I will keep 8 o'clock. 8 means you're 9:30.
9:30, 10:30, 11. No, yeah. Means because we have to practice also the next day, right? So, and my start, like for example, my office starts at morning 8 o'clock. It starts off. My team is very early to start working upon. Okay. Yeah. Generally. Yeah. Okay. I just wanted to understand all those things. Okay. Before I need to assess my time and all those things. Correct.
Yeah.
How would I manage my time and all those things? I have to be honest to the subject, right? If I'm learning, I have to learn it seriously.
Yes.
Got you.
Do you suggest any book like to start with books?
Yes, there are some few good books for this one. Okay, Hadoop definitive guide when it comes to Spark, Learning Spark. There are some books. I'll share that books links with you whenever I start that particular module.
I'm following Big Data Art textbook published by Packet, something like that.
Okay, so there are many books actually. Every other writes that in a different way. So one standard book for this is Hadoop definitive guide for Hadoop. That's from ORLE. And there are Learning Spark. There is a good book, Spark Definitive Guide, Learning Spark. There are two good books, even if you're preparing for certification. So they're good. Okay, and moreover, I forgot to mention there is one more thing called Databricks.
Yeah.
What in Databricks exactly you are teaching on?
So
there?
see,
Yeah.
Databricks is a company who is actually mainly, I mean, the guy who actually invented or built this Spark framework. He open sourced it later, but he is the same person. He started his own company called Databricks. So Databricks is a one cluster computing platform. So this Databricks, if you want to build a Spark cluster ready-made, Databricks provides the environment in Azure cloud or Google cloud anywhere. Databricks has their platform on the any cloud. You can just you can easily create a cluster and you can start working on Spark there. Databricks is the Spark cluster.
Okay.
So these days, most of the companies are using Databricks because it's easy to manage.
Yeah, we waste a lot of time in like setting up of this only.
Yes, we don't. That's what as a developer, we should not scratch our head on setting up the things, right? So Databricks is that process. If you want to scale up, I have 10 nodes now. Whenever the load is increases, I want to increase it to 100 nodes. You can do that using Databricks just by simple setting.
Okay. So will you be teaching the thing in Databricks, or it will be a concept in Databricks only? Because you said GCP, we have to be in GCP. We have the data block.
GCP. Okay, so later, because if you start working on GCP right now, you'll have to pay monthly some 500,000 rupees, 500,000 rupees monthly. So till I cover this Spark concepts, you will be on data proc. Later you can reach with the AWS.
Okay.
In EMR actually they give only 1 GB RAM, and single core CPU for free. Okay, which is good for nothing.
Yep. Yeah.
That's but Google Cloud doesn't have that limitation. You want some 20 GB machine, you can take it.
Got it.
All right, so Ravi, will we be working on UGs and like implementing all those pipelines, or we will only be implementing the hbase or whatever code we are going to implement over the Python? Yeah, UG, right? Yeah.
UG is actually not a development tool. Okay, UG is a orchestration tool. Okay, so UG is like, okay, I can cover some UG concepts. Okay, UG is like orchestration. Orchestration means first I want to run some scoop, then I want to run some shell script. After that I want some Hive script. After that I want to run Spark script. After that I want to run some other script.
Yeah.
So this kind of orchestration you can do with this UG.
Yeah.
UG has the coordinator. Okay, so with that you can actually schedule how frequently you want to run this pipeline.
Yeah.
Okay, so UG, you will always write all these things in XML file.
So regarding Kinesis, right? The Kinesis is basically a streaming, right? In AWS, they use extensively Kinesis for streaming, right? So, how detailed will you be going in Kinesis with?
There are two things in Kinesis streams and the Kinesis other one. So I'll be going to that, creating a Kinesis cluster and receiving some events with that, processing those events with EMR. Okay, so that way I will cover.
Okay, means we want to say if the ingestion of the data that is coming through streaming, you will be doing ingestion of the data and then finally getting into the final tables, right? That's the life cycle, the pipeline you will building.
Yes.
Correct? Okay. Yeah. Okay.
Like for example, data is coming, okay, and that going to Kinesis. From Kinesis, you are giving to EMR Spark streaming job. From EMR is storing into some DynamoDB or Redshift or any other Hive or anything.
Okay.
That's one pipeline, right?
Yep. Yes. Yeah. It is a pipeline. Yes. So in this whole gambit that you're teaching, right? In this one, do you anywhere make into? Do you have any place for CI/CD?
No, I'm not teaching the CI/CD because that will become so
more
fast.
of dev. Okay, no, yeah, because when we develop pipelines for us, right? Like when
normally companies these companies are having separate DevOps team who actually take the CI/CD.
Yeah.
So I mean, even interviews, no one will stress you or ask you on the CI/CD because you are the data engineer, a big data developer. So if you are good with your core concepts, you are good.
Got it.
Like I have another Like you train so many students, right? When they're getting on board, what type of work they are getting? Are they staying in the same work or getting?
See, that depends. Some companies, they just start with the big data projects. Some companies are ongoing projects. Some companies, they just want to support their maintenance projects. Okay, they're based on. Okay, some people they actually get very scratching projects. They just to start developing the pipeline, like orchestrating or engineering the pipeline. Some people already going to existing projects. Okay, then they'll get some module. Okay, I'm getting this data now. This process this data. Use this scoop or use this hive or this write Spark scripts in EM or some other place. Okay, so that's completely based on the project where they are going.
You have anything else, Ravi, to say? But it is a good introduction. I really appreciate you took the time to explain these things.
Thank you, Arvind. So you connected with other Ravi? Arvind? Hi, Shiva.
Hi. Sorry, I'm late. John late. So, my question is it for the fresher or just like I don't know anything about the I know some like SQL but not I
Okay.
didn't have much knowledge
Okay.
about
So
database.
yeah, good question. So fresher means not any company hiring say the fresher
Sorry.
because they're working on good amount of data, right? So normally, so you need to know some more concepts. That's way many. So all those some at least you need to know. You need to start work with
Yeah, repeat that again. I know there was like a
least
background.
at least companies expect 2 to 3 years experience. I mean, very few companies hire the freshers and big data. At least they expect them 2 to 3 years.
Okay. Okay. So, what you recommended, like before, join this, join this your course, what kind of knowledge I should get, like.
Okay, so since you're good with the SQL, because SQL is very much important because wherever data is there, SQL is there. In Spark
Mhm.
SQL, in Spark we have the Spark SQL. Okay, with that you can write SQL queries. In Hive we need SQL queries. Okay, in Spark Spark SQL queries needed. So SQL is the prerequisite for this one.
Okay. The reason I'm here that my current company they work with I mean they have a Hadoop environments and we have to support so that's why I just want to uh no good I want to learn about good architecture of Hadoop environment and so that's the reason I was
Okay.
here.
Okay, so I just passed my number in the chat box. Okay, you can
Mhm.
connect me offline.
Okay,
We can
sounds
discuss.
good.
Okay. And sure, when are you planning to? When are you planning to start this one, the whole thing, Ravi?
I'm actually continuing. Maybe for next 2-3 days, I will take the if anyone else is coming to the batch. Okay. Okay, I'll continue the sessions from tomorrow.
Means we're starting the session from tomorrow. That's what you're saying?
Yes, starting the new batch from tomorrow. Today is kind of introductory session to like meet the new people.
Oh.
So if anyone else comes in the next few days, I'll take them.
Got you.
but we'll continue.
Okay.
Sagato, any other questions?
No, I'm good, Ravi. I'm good. Thank you.
Yeah, I'm good to Ravi.
Venkat?
Yeah, I am good.
Okay. Shiva, connect. Since you joined late, maybe we can have one session or join. Connect.
Yeah, sure. Yeah, I'll probably text you.
Okay, guys. I have one more
Okay.
session.
Thank you.
Yeah.
Thank you.
Thanks, Ravi. Yeah, thanks, Ravi.
Okay, Ravi, thank you.